Hello and welcome to our exam question practice on the particle model of matter. Starting off easy, we'll start with some multi-choice questions, and these are suitable for both foundation and higher tier. Blue question is about the density of substances. We're going to look at what units are used for mass. Then we're going to do a little bit of equation rearranging up here on the right hand side with the density equation formula, and then we're going to go on to use that formula to calculate the density of a substance. You can either go straight along and do the answers with me, or you could pause the video and try them for yourselves. Okay, hands up who paused the video. Nobody? I thought so. Right, so let's have a look at the density of these substances. Hydrogen, we should know, is not dense at all. Then we've got two medium elements there, but right at the bottom we've got good old heavy lead. So this is the most dense substance, and it's right down in the periodic table. Next one, come on, this is an easy one. I haven't weighed myself in newtons for quite some time, so what we want here is kilograms. Up on the right hand corner here we've got the density equation formula, and I've popped it in a formula triangle for you. We need to use this to calculate the volume of something, so we need to cover up the V. That leaves us with m divided by d, which is mass divided by density. So our formula is V equals m divided by d, and that's given by A here. So let's go on and use this formula now to actually calculate something. We've got a material with a mass of 20 kilos and a volume of 5 meters cubed. So let's take that mass of 20 and divide it by the volume of 5, and what we'll come out with is 4 kilograms per meters cubed. Right, now we've warmed up, let's go on to some short answer questions. So we're going to have to think about these a little bit more. First one about what happens to a substance as it's heated. Then we're going to have a look at a change of state from a gas to a liquid. Then we're going to have a look at how we can alter density, and a quick question there on heating and cooling graphs. Press the pause button if you want to try it yourself, or come along with me. And here are the answers. These are worth 2 marks, so it's good if we can get 2 points into each one. How does the density of a substance change as it's heated? Well, the density decreases, and this is because the particles of the substance gain energy and they can move further apart. Second question is, what do we call the process when a gas changes into a liquid? Well, if we think about a kettle, the steam coming out of the top and hitting a cold window, we call that condensation, and that's exactly what the process of a gas turning into a liquid is called. Next one is, name 2 ways in which the density of a liquid or a gas could be altered. 2 easy ways really. We can either change the temperature, heating or cooling it, or we can change the pressure. And the last question, if we look at a heating and cooling graph, we can see flat areas on the graph, and this is showing that there's no temperature increases at these points. Okay. Now we get down to the nitty-gritty. This is an extended answer question, and this is suitable for foundation and higher. We need to describe what happens to the particles in a solid when heat energy is applied. And it says to refer to the properties of particles during and after a change of state, and to discuss any temperature changes. Right, 6 marks. We need 6 good points here. So note them down, pause the video, or come along with me for the answer. And here's the points I found for the answer. I put, as heat energy is applied, the temperature increases, so the particles move further apart. There's a good few points in there. Once it reaches the melting point, the solid starts to change state and becomes a liquid. This is obviously called melting. No surprise there. In this process, the old bonds are being broken and the energy is used up. So that means there's going to be no energy to cause a temperature increase as the solid is melting. Now, when it eventually becomes a liquid, the particles are further apart and they're able to slide over one another and act how we know a liquid does. I think that's covered most of the points that we can make about that. Right, on to another extended answer question, and you only need to worry about this one if you're higher tier. Gas cylinders used by scuba divers need to be at a high pressure, And the scuba instructor fills the tanks in the shade on cooler days. So let's explain why he might be doing this. Right, pause to think about your answer or come along with me. Right, this is what I thought about this one. I think he would fill the tanks on cooler days because the gas would actually be more dense at the lower temperatures and he could fit more gas in the tank. That means that when the warmer days come along, the gas would expand and produce the high pressure in the tank that's needed. If he filled the tank on a warm day and then it was to be used on a cold day, there would be a real problem because the tank wouldn't be at such high pressure. So I think that's covered most of the points of that one. And another higher tier question just to finish us off, and everybody loves a bit of maths, don't they? So let's have a look at this. It's all about specific latent heat, and they've very kindly given us the equation below, energy equals mass times specific latent heat, and they've even given us the specific latent heat of water. So, how much energy is needed to melt 20 grams of ice? And then the second part of the question is asking us to estimate the energy to turn 15 grams of ice into water. So, you might want to pause the video for this one because that's a tricky calculation, and don't forget how we measure mass in this equation. Okay, hands up. Who put 20 grams into the equation? Yes, yeah, most people. What we need to remember about this is when we start this calculation is that in the equation mass is in kilograms and we've been given 20 grams in the question. So first of all we need to change mass from 20 grams to 0.02 kilograms. Then we can do the calculation, energy equals mass times the specific latent heat, and that gives us an answer of 6,680 joules. And from basic mathematics, the second part comes, if we've got 6,680 joules for 20 grams, then if we divide this by 20 and just multiply by 15, we'll find out how much energy we need for 15 grams, which is 5010. That completes our exam extended answer questions and this presentation. Thank you for listening.